Have you ever, really stopped to think about what's happening when you click on something online? It just works. Feels like magic, right? Well, it's not. Today, we're going to pull back the curtain and show you the incredible hidden journey your data takes every single second. So, the absolute best way to wrap your head around all this is with one simple idea. I want you to think of the internet as a gigantic, worldwide postal service. Every single thing you send, an email, a text, a picture, even a tiny piece of a video, is basically a package that needs to be perfectly addressed, shipped, and delivered. And that is the billion-dollar question, isn't it? How on earth does a digital package travel thousands of miles through this ridiculously complex web of cables and machines and get back to you in literally the blink of an eye? Well, to figure it out, we're going to follow one of those little data packets on its big journey. Okay, so if we're using this postal service analogy, our first stop has to be the post office itself. Before we can even think about sending our package, we need to understand what a network even is. You know, how they all connect together to form the internet we use every day. At its most basic level, a network is really just a way for machines to talk to each other. I absolutely love this analogy on the slide. It's a social circle for machines. Your phone, your laptop, your smart TV, your gaming console, they're all part of this little club, sharing stuff, like a printer or, the most important resource of all, that sweet, sweet internet access. And here's where it gets wild. These little social circles scale up big time. That small network in your house, that's a LAN, a local area network. Now connect all the LANs across an entire city, and suddenly you've got a MAN, a Metropolitan Area Network. But when you connect everything, all the MANs, all the LANs across countries and oceans, you get the ultimate WAN, the Wide Area Network, which we just call the internet.
All right, we've got the 30,000-foot view. Let's zoom all the way back down. Our data packet's journey starts right where you are, inside your home network. So let's meet the team of hardware that's responsible for getting your data packed up and shipped out.
Think of this as your own personal shipping department. First, you've got the modem. It's the gateway to the big wide world, translating the signal from your internet provider. Then there's the router. He's the traffic cop, telling every single packet exactly where to go. And finally, the access point, or AP, is what actually creates your Wi-Fi signal. Now, I know what you're thinking. Most of us just have one box we call the Wi-Fi router, right? And that's true. These days, the router and the access point are usually smushed together into one device, but they're still doing these two very different, very important jobs. So our package is all packed up and ready to ship. But listen, for a global postal service to work without turning into total chaos, every single machine has to follow the exact same rules and use the same addressing system. It's time to take a look at the internet's official rulebook. Whoa, okay, that looks complicated. Don't worry, don't tune me out. This is called the OSI model, and it's basically a 7-layer cake that explains how data moves. What's really great here is the little mnemonic to remember the layers. Please do not throw sausage pizza away. All we really need to know is that these layers handle everything, from the physical wires at the very bottom, all the way up to the app you're looking at on your screen at the very top. Okay, this is fascinating stuff. Just like a real-world package, our data needs two different kinds of addresses to get where it's going. First, there's the MAC address. Think of this like your social security number. It's burned into the hardware at the factory, it's permanent, and it uniquely identifies that one device. But then you have an IP address. This is more like your mailing address. It tells everyone where you are right now, and it can change if you, say, take your laptop to a coffee shop. It's a perfect system, right? One identifies the device, the other identifies its location. And it turns out we need a lot of mailing addresses, a truly mind-boggling number. The original system, called IPv4, is pretty much all used up. So the new system is called IPv6, and the scale of it is, well, it's hard to comprehend. As the slide says, it provides enough unique addresses for every single grain of sand on the entire planet. Just let that sink in for a second. That's the scale we're operating at now. So our devices have these number-based addresses, but let's be real, you and I are never going to remember them. That's where something called DNS comes in. DNS, the domain name system, is basically the internet's phone book. It's brilliant. Look at this diagram. When you type a website name like example.com into your browser, your computer sends that name out to a DNS server. That server looks it up, finds the matching number, the IP address, and sends it right back. Now your computer knows the exact numeric address of the server it needs to talk to. Okay, our package is addressed, we know exactly where it's going. Now it's time to choose a shipping method. And just like with real-world shipping, it all comes down to a classic choice. Do you need it to be fast or do you need it to be reliable? And there are two main ways to go. The first is called TCP,
and you can think of it like registered mail. It's all about reliability. TCP carefully checks to make sure every single piece of your data arrives, and if anything is missing, it'll ask for it to be sent again. You absolutely need this for things like websites or emails, where every letter counts. On the other hand, you've got UDP. This is more like shouting in a crowd. It's way, way faster, but it doesn't double-check to see if you heard everything. This is perfect for live video streams or online gaming, where a couple of lost pixels here and there are no big deal, but speed is everything. Our data packet is now zipping across the public internet at nearly the speed of light. But this journey can be a little dangerous. How do we make sure our digital mail isn't being opened and read by someone else along the way? Well, it's time to meet the security team. Your data basically has 3 digital bodyguards. First up is the firewall. Think of it like a bouncer at a nightclub door. It checks all the incoming traffic and just blocks anything that looks sketchy or isn't on the list. Then you have HTTPS. This is the secret code. It scrambles or encrypts your data so that even if someone does intercept it, it just looks like gibberish. And finally, a VPN goes a step further by creating a completely private encrypted tunnel for all your activity, hiding your entire journey from start to finish. And hey, here is a really simple but super powerful tip you can use every single day. Whenever you're on a website, just glance up at the address bar. If you see that little S in HTTPS at the beginning of the address, you know your connection is secure. You know one of those digital bodyguards is scrambling your data. That S literally stands for secure. And there you have it. From one little click, your data packet was packed, addressed, shipped using the perfect method, and protected every step of the way, all the way across the globe and back in less time than it took me to say this sentence. It's an absolutely incredible system that already connects billions of us. But understanding that whole journey, from the modem in your house to the security protocols protecting it, that's the key to figuring out the answer to this final huge question. What's it going to take to build this for everyone else?